Hello, welcome back. In this week's lessons, we're going to talk about taking a small sequence of notes and then using that sequence, manipulate it, combine it with itself to generate an evolving piece of music. In contrast to last week's lesson, where we basically created more or less like a random mapping to notes, this week is going to be a little bit more structured. So we're going to be defining a sequence that repeats over time, but then stretching that sequence, transposing it, and layering it with itself to create our composition. We're also going to be talking about mapping values to musical notes in a bit more of a flexible way. We'll do a little bit of visualization of our musical piece as it plays. And then in the end, we're going to apply some randomization rules to our sequence so that we basically create this ever-evolving composition. But first, in this lesson, we're going to start to focus on mapping musical notes, mapping numbers to musical notes. So what I've done is I've simply just remixed our blank sketch. Remember, we're including now the two libraries, right? Tonal and tone.js from now on in our blank sketch. And I've created a little bit of boilerplate here in the interest of time. I'm going to go over it very quickly. So we have a ready variable, and the purpose of this variable is to trigger something when the mouse is pressed. So when the mouse is pressed, we set ready equal to true, which means this is only going to happen once. And then we have a place where we can initialize our audio. If you'll remember, with tone.js, it's important to wait until the user has interacted with the browser window before doing audio initialization. So we're going to comply with that by doing all of our audio initialization only when the mouse is being pressed. And I've packaged this into a function, so it's a little bit easier to manage. So currently we're just lowering the master volume, and I have a variable here set to -9 decibels, and that's just I want to make the sound a little bit quieter because I'm going to be talking over some of that audio. And then in draw, we have a simple little if here that allows us to branch based on the value of ready. So if ready is set to true, we can do something. Otherwise, we show some prompt to the viewer to click into the window, and that's the text bit over here. All right, so let's talk about mapping numbers to musical notes and why we might want to do that. So first, let's create a scale, and that's going to be an array of notes. And we saw in the last lesson, we could use the tonal library to help us generate scales if we don't know them, if we don't know how to build them from scratch. So the tonal library has a scale object, which has a get function, and then you give it the name of a scale. So for example, we're going to ask for the C4 major scale. So the major scale that starts on the note C4, and then we'll get the notes from that scale. And then in draw, we are going to map our mouse cursor just for this example. So when we are on the left side of the window, we're going to get the first note from the scale, and then we're going to progress through the scale as we move to the right. So let's call that note index. And we're going to map the mouse cursor here. Let's call it note number. We're going to map the mouse cursor. So mouse X, that varies between 0 and width. We're going to map this to a number between 0 and scale.length, which is how many notes we have. And here, the output of map is going to be a floating point number. So we're going to use the floor function, which is going to round that number down so we have an integer. And then just so we see what we're doing here, we are going to just put in a bit of code to draw some text. Let's see. I'm going to center the text. I'm going to make it pretty large so we can see it. And then we're going to show our note number using the text command just in the center of the window. This is so I don't have to use the console. It's a little bit easier to see. So as I'm moving from left to right, you can see I'm getting a 0 here, and then I'm getting a 6. And we can use this number as an index into our scale array. So instead of note number, we could use scale bracket note number, and then we can get a note instead. So the C4 major scale, right, starts on a C4, and then we go through all the white keys, right, all the way to B. Now, because we're in using Tone.js, let's also really quickly make a synth object so we can play those notes and hear them. It's going to be a little bit more interesting. So I'm going to define a global variable here. I'm going to call it synth. And then in the initialize audio, this is going to be a new tone.synth. And of course, after I create the object, I also have to connect that sound source to the destination. And if you remember, the default destination is tone.master. So that's if I don't do this step, I'm going to create the synth, but I won't get any sound. I have to connect the sound generator to the output or to some other sound block in the chain. And now that I have a synth, when we have a new note here, we can also play the note. So we're going to say synth.trigger attack release. So we're going to trigger both the attack and the release at the same time. We're going to play the note, and we need to give a note duration. So let's put an eighth note here, just a short note. Okay. Now the note is like constantly triggering right now because this is in draw, right? So that's why it has this sound where it sounds like a long sound, but really it's a stream of notes being triggered really, really fast. So let's improve this a little bit. We're also going to create a variable here. We're going to call it previous note. And we're only going to play this note if the new note we generated up here is different from the previous note we played. And if that's the case, we're going to play the note, and then we're going to make previous note equal to the note we just played. So now it's only going to play a note whenever the note is changing, essentially. So okay, so I can go through the notes of my major scale, and I can map a number. In this case, I'm mapping mouse X to sort of move through that scale. And this is what we did last week. But this is a little bit limiting, right? If we bring up this keyboard here real quick. Currently what I'm doing is I've generated the major scale starting on C4. So that's over here. And the major scale is easy because it's just all the white notes. Okay? Other scales will include some of the sharps here, the black notes, but we're just using the major scale for simplicity right now. So my major scale, right, is and ends on a B here. Now it would be nice, for example, so that I could map my mouse cursor to, play an extended scale where, if I want to go down here, I'm still in the major scale, I'm just an octave lower. Or over here, I'm still in the major scale, I'm just an octave higher, right? So if I wanted to map the whole range of this keyboard to my mouse movement while remaining within the major scale. So it'd be nice if I could do that. Now, there's a few ways we could approach this. Last week, we took a simpler route, which was just make our scale array bigger, right? We've included other octaves of the major scale into that array. That's a little cumbersome, and today we're going to develop a simpler or maybe a more flexible approach to mapping notes. Okay? So we're going to come up with a system where if our scale starts on a C4, right? If I wanted to get a B3 here, I would put in a note number, right? C4 would be our note number 0. If I put in a -1, it'd be nice if I could land on a B3. Similarly here, if this is our last note 6, if I put in a 7 for a note, it'd be nice if it kept going. It gave me a C5, right? So we're going to be able to extend infinitely, right? Above and below our main scale that only contains the 7 notes of the major scale. The only thing we're deciding is where that scale begins. So here we're starting on a C4. So we're going to rely heavily here on this idea of modulo to sort of keep wrapping around within this scale. But at the same time, we're going to have to do a little bit of calculations also to figure out, which octave we want to be on and then which note we want to be playing. So let's build this through one step at a time here. So first, let's talk about here. We're going to change the mapping here for our note number. So for example, instead of going from 0 to the number of notes in our scale, it would be nice if we wanted to play this whole keyboard. Maybe we want to go from -7, which would be a whole octave lower, all the way to, let's say, 14, which would be a whole octave higher. Now, if we do this, we're going to have some issues. So we're going to, right? I don't have any valid notes anymore here. And that's because we're exceeding the bounds of our array. So instead of drawing the note here, let's draw the note number we're generating to see what's happening. Okay, so now I'm going into negative numbers, which is what I want. So here I would like to get, -7. -7 on my keyboard, if I'm starting here, right? -7 would be a C3. And over here, plus 13, right? I would end up over here. So how can we do this? So the first thing we're going to do is figure out, okay, if I have this number, right, we know we want to stay within the same scale. So we're going to not worry about the octaves, just worry about what's called the pitch class of the notes, which is the letters. So we know that our array contains 7 notes. So we're going to write some code that's going to keep the note number, right, within the boundaries of the array. And then afterwards, we'll figure out how to add the correct octave. So we're going to generate an index that's not going to be note number. And let's start first with the modulo operator. Okay, so we're going to say note number, modulo. And here we're going to do a modulo based on the length, right, the size of this array. So let's make this into a separate variable so our code is a little bit clearer. So the number of notes, right, or number of notes, that's going to be equal to scale.length, right? That's the number of notes in our scale. If we take modulo number of notes, let's see what happens. Okay, so this actually gives -1 all the way to 7, right? So on that side, we have some issue. On the positive side, we should use I, not note number here, just to see what number we're generating. Okay. So if I go up, right, when I reach 6, because I'm using modulo, it's going to wrap around, essentially. It's going to go back to 0 as I move my mouse. Right? The only issue is we're not hearing notes because we should use I here as our scale index. Let's try it. So now it's going back into the array to the beginning. It's not increasing octaves yet. We haven't put that in. But now we're able to sort of loop around and repeat within the same array of notes. Now the problem is when we go to 0 and we go the other way, here's what happens in JavaScript when we do a modulo with a negative number. Oh, we get a negative number out of that operation, right? So now I've done -1 modulo number of notes, I get a -1 out. Now that's a problem because we don't have a -1 index in our scale. We want to keep this index from 0 to 6. Normally with modulo, there wouldn't be a negative reminder. The only problem is in JavaScript, the modulo operator is a little bit deceiving. It's not a proper modulo operator. In fact, it's just a remainder of a division, which is not exactly the same thing. So we're going to fix that here. So we're going to get a number, right, that goes from -6, and it's going to repeat that way to 0. So let's bring that number back into the positive range. So we're going to do more of a proper modulo here. We are going to add the number of notes that we're doing the modulo by to that number, first of all. Now, this is going to become too large. So in addition to doing this, right, let's look at it first on the negative side, right? So now when I go from 0, okay, so these numbers are now in the correct order. If I go from 0, right, I get 6, 5, 4. This is taking me through my array of notes, right? 6, 5, 4. It's taking me in the right direction. What I now need to do is make sure I don't exceed 6. So we're going to take that whole number and we're going to do another modulo operator or reminder by number of notes. So now if I go to the left, I'm going to get a B, back to C, and now it works in both directions as well. So we're now able to cycle through the scale array as I move my mouse from left to right. Now we are repeating the octaves right now because we haven't put in the code yet, but we're able to now generate an index, right, that's going to properly wrap around in the correct direction inside this scale array. So this might be useful down the road. So let's package this idea here as a little function. We're going to call it modulo because this is the proper, the proper way of doing modulo and not just a reminder. So let's take this idea here, put it into a function, and instead of, so here if you say modulo of a number n by m, we're going to replace note number by n, and then number of notes by m, just to make it a little bit more general, right, in case we ever need to reuse that idea. And here we can write modulo note number by number of notes. Number of notes, like so. So back to the same place. Okay. All right. Now let's try to figure out the octave portion of this problem. So what we want to do here is we want to figure out which number to add, right? So we can get the right note we want to play by saying, let's call this note name. Okay, we can use tonal for this. Tonal as a note object, and if we give it a note, we can use the pitch class function to extract from a note, let's say a C4, if we're only interested in the C portion, right? Just the name of the note, we can use the pitch class function. Let's see what that looks like. I'm going to draw the text here so we can look at it. So if I'm doing pitch class, what I'm doing is I'm taking out the octave number and only ending up with the name of the note. So now we're going from C, right, back to C, back to C, and we end at B here because we don't get quite all the way to 14 because of the math. Okay. All right. So this first note here should be a C4, right? And then moving to the left, we should get -1 in our octave, a -1 offset, and then moving over here, we should get a +1. So let's figure out what our baseline is. Let's call this the 0 octave. So the 0 octave is going to be the octave of the first note in our scale. So if I started on a C4 here, we're going to make our 0 point, or what happens when I want note number 0, right? Which octave should that be? Well, that's going to be the octave of the first note in the array. And we can use tonal just the same way we extracted the pitch class. We can use tonal to give us the octave. So we'll say scale bracket 0. Okay, so this is going to be the octave of the first note in our array. And once we have this, what we need to figure out is now we need to say, okay, well, do I need to add or remove from this, right? Depending on where I am. So we're going to say, let's call this note octave. It's going to be the 0 octave. And then to this, we're going to add an offset. So depending on our note number, right? Depending on the note number that we generated, or we're going to divide this by the number of notes. And we're going to round this down as well. So if this is 0, right, we're going to get a 0 offset. If this is -1 or -4 or -3, we're going to get a -1 offset. And if this is a positive number that exceeds 6, we're going to get a positive offset, right? And that's going to increase by jumps of 6 or number of notes here. So let's draw this as well. So we have note name, and then we're going to add to this the note octave. Okay. Now we're not hearing the right note here because I'm playing this note variable. So what we are going to do is at the end, when we're done here, we're going to say note is going to be equal to note name plus note octave. And then we're going to draw the note that we're playing. So if I pass in a 0, right? And then let's also put in the note number. Just so we can see the relationship between the number and the note. Okay. So here, when my mouse is about at this point, out of the map function, I'm getting a 0, which means this is the first note in my scale that I generated. If I put in a -1 as my note number, I'm going to get, let's bring the, oh, I closed my keyboard by accident. I'm going to get the note moving, let's start the keyboard again. Okay. See, I'm going to get the note to the left of the first note in my scale, right? This is a -1. And then we could keep going the other way as well. So 6, right, is a B4, is the last note in our major scale. If I go to 7, I get a C5. Right, I get the next note in the next logical note in the progression if we continue looping the notes from the scale. So this is really useful because now we can make this range kind of arbitrary, right? We could say go from 2 octaves down, let's say, to 2 octaves up. So now essentially what we've created is we can take any changing quantity, right, like mouse X or some other number. We map this to a range of discrete notes we're interested in, thinking of 0, right, as the first note in our scale, right? So whatever the first note in our scale is, that is the 0 note. And then if we go negative, we're going lower pitches. And if we go over, right, if we go above the last note in the scale, we're just increasing the pitch. And those boundaries, right, we can set them to be anything we want. And this way we can define, any scale. We could switch here to a minor scale. Now the minor scale doesn't have just white notes in it, but it doesn't matter. Has some flats. The idea still applies, right? So we start with a set of 7 predefined notes for our scale, and then we can extrapolate from this lower octaves or higher octaves. So that's going to be very useful when it comes to transposing melodies or taking a small melodic pattern and then making it extend, right, in either direction. So let's take this code before we move on, and let's package it as a function so we can reuse it in future programs. So we're going to call this function map note, and it's going to take in 2 parameters. First, it's going to take the note number, right? And then it's going to take an array that's going to be our scale that we want to map into. And I'm going to use these names because this way I don't have to change too much in the code here. So let's bring in these lines of codes into map note. And then here at the end, when we finally calculated our final note name, what we're going to do is just return this value instead of just calculating, instead of just putting this into the note variable. This is just complaining here because of the formatting, so I'm going to fix it with the format the file. Okay, format the file. And then over here, once we have a note number, we can say let note. We're going to get rid of this here. We can say let note equals to map note, note number, scale. So now we've encapsulated this idea of translating a note, right, from a standard scale of 7 notes, either to lower or higher registers. We've encapsulated that into a function called map note. So now if I pass in a note number, whether it's within the scale, that's 0 to 6, or above, that's 7 and beyond, or lower, that's -1 and less, I can give any scale, any note number, and get a musical note out of it. Cool. All right, so we're going to reuse this idea in the next few lessons. We can just kind of package this up here. So we've done a couple of things. First, we've created our own modulo function, right, just to get a proper modulo here, which means if we give it a negative number, it's not going to return a negative index. It's going to return a positive number. Just keep it within 0 to 6 or whatever the length of scale is, because we might have shorter scales as well. Then from there, we've separated this idea of the note pitch class or the note name from its octave. And we said the 0 octave is simply going to be where a scale begins. And then from that point on, we figure out if we need to add an offset to that, right? If we're lower or higher, we do plus or minus to that 0 octave. And then we combine those two things back into a note. The note octave and the note name just get glued back together here. These, when we add them together, this is a string, this is a number, so they just get glued together, and then that gives us our final note. All right. So with that said, I'll see you in the next lesson where we're going to take this idea and apply it to a short musical sequence or pattern. See you there.